Hello, Physics 2212, Lab 4, Magnetic Field of a Bar Magnet. Introduction. The purpose of this lab is to measure and explore the distance dependence of magnetic fields using both experimental methods and GlowScript code. Preview of results. N is equals to minus 2.5298. Magnetic dipole moment is equals to 5.691. Physics principles used. In this investigation, we're using Biot-Savart law, which relates a magnetic field at a point to an electric current. Magnetic field, and we're also using magnetic field caused by magnetic dipole, the equation for that. And we're also using the distance-dependent formula of a magnetic field. And the assumptions we're making is that bar magnets can act as a magnetic dipole so that the Biot-Savart law can be applied. So the experiment. The setup, so first of all, the system is the bar magnet, surroundings is everything else, and initial conditions is a net magnetic field of 49 micro teslas. Procedure. Phone is slidden horizontally on a ruler with a magnet at the end until the maximum X value was found, and the tape was placed on the phone. At max X value, the phone was slid vertically until max Y value was found, and another piece of tape was placed on the phone. The distance between the magnetometer, the phone, and the bar magnet using the tapes was measured. So after this average distance at which the X component was a range of certain numbers found, and these values, after this, the average distances at which the X component was a range of certain numbers was found, and these values were tabularized and then linearized. Through calculations with the equations found in the slope, I found that n is equals to minus 2.5298 and k is equals to 1.138 times 10 raised to the power minus 6. And through these, I found that the magnetic dipole moment used equals to 5.691. So now the off-axis part of the experiment. We also measured the values of the magnetic field at the D perpendicular and found that the average of these values were recorded in the table below. So now for the code. I inputted the value I calculated for dipole moment into the code and created a function to calculate magnetic field. So here you can see that the value I got for dipole moment is there under mu mag, and the function to calculate dipole moment is there under define dipole moment, dipole B, MUR, and shows the equations to find R magnitude of R hat, and also the magnetic field B, and it returns the value of B that you evaluate. And then I also wrote code to be able to observe the field from different locations. So 2 on-axis locations and 4 off-axis locations. And as you can see, there's 2 locations where they are on-axis, and then two arrows are shown to be on-axis, and 4 arrows are shown to be off-axis, or specifically perpendicular to the axis. And you can see that, and you can see this when I run the code, and these are the image I got from running the code. I ran the code and got my values for computed B field at a 45-degree axis with the two on-axis observations, which observed the magnetic field at these locations and 4 off-axis. And the values collected from the code are very similar to the calculated values, but there are still some discrepancies, as with all calculations. So sources of error. There may have been some other magnetic object in the area. It was done in a classroom, so things like my bottle and my laptop might have affected the results a little bit. Also, there was some error in finding the north and south of the magnetic pole of the Earth and positioning the magnetometer, which is the phone, in the right place. Observations. When the magnetometer is far away from the magnet, it measures a near zero magnetic field in the X direction. And as the magnetometer moves closer to the magnet, the measured X component of the magnet field increases. What if? What if you hadn't oriented your experiment to compensate for magnetic north and had instead laid out your meter stick at some intermediate angle with respect to Earth's magnetic field? How would your results have changed? The Earth's magnetic field would have interfered with the results gotten from the bar magnet's field, so they wouldn't have been as accurate. What if you were to stick 2 identical magnets together and run the experiment again? How would you expect the measurements to differ? the magnitude of the magnetic field would double, but the direction would stay the same. Thank you.